Good morning. Today is October 3, 2017, and the Nobel Prize for Physics was announced this morning at 5:45 a.m. my time. That was 11:45 a.m. in Stockholm. I got up already at 4:30 my time. I just couldn't sleep. And I watched the announcement from Stockholm live on TV. As I expected, my friend and former colleague at MIT, Professor Rai Weiss, shared the Nobel Prize with Kip Thorne for the detection of the first gravitational wave in September 2015 with LIGO. I urge you to Google LIGO, L as in lion, actually L as in Lewin, I as in iceberg, G as in George, O as in Otto. There are two parts of the LIGO detectors. Each are 4 kilometers long. One is in Louisiana and the other one is in Washington State. It was my friend Rai Weiss who about 45 years ago had the vision that the only way, perhaps, that we could ever on Earth detect gravitational waves would be to use an interferometer. Einstein's prediction in general relativity of the existence of gravitational waves was exciting, but he himself never believed that it could be detected on Earth, because the effect would be too small. Gravitational waves alter space. There's a change in space-time. So what is this long now may not be this long when the gravitational wave passes by. Depending upon the frequency of the gravitational wave, it may do this and then come to a halt again. So at the end of each 4 kilometer LIGO detector, at both ends are a mirror. And in a fantastic way, largely due to the brilliance of Rai Weiss, these mirrors don't move. It's hard to believe that you can build anything that wouldn't move. That's why you should read up on it. And the idea then was, since there was an interferometer between these two mirrors, that as the gravitational wave would pass through the Earth, that the mirrors would oscillate, indicating a gravitational wave detection. And the first great success was on September 14, 2015. It therefore called GW 150914. The signal that was received lasted only 1/10 of a second. It was received at both detectors, by the way, both in Louisiana and in Washington State. The signal lasted only 1/10 of a second. It started out at about 35 Hertz and it ended at about 250 Hertz. It was immediately clear on the basis of theoretical grounds that what was happening is that 2 black holes would spiral into each other and merge to become 1 black hole. They were even able to calculate the masses of these two black holes. One was about 36 times the mass of the Sun, and the other one about 29 times the mass of the Sun. 3 solar mass of energy, in terms of mc squared, imagine how much that is. 3 solar mass of energy went into gravitational waves. So the merging black hole, the 36 plus 29, would have been 65 solar masses. But 3 solar masses went into gravitational waves. So the emerging black hole was only 62 solar masses. The object is about 1.4 billion light years away from us. Now comes the mind-boggling thing. Hard to believe. But that's why someone like Rai, a genius, thought of this. During the gravitational wave on September 14, 2015, the change of the distance in the two mirrors at maximum, that was doing this, was 250 times smaller than the size of a proton. So they were 4 kilometers apart, and the detector is so sensitive that it could detect a change in distance which was 250 times smaller than the size of a proton. I had hoped that Rai and Kip Thorne would get the Nobel Prize already last year, 2016. However, the deadline for nominations of the Nobel Prize is January 31. And this spectacular result of September 2015 was published on February 11 that year. So it was after the nomination. So therefore, they didn't get it last year. I have known already for more than a year now that they would get the Nobel Prize this year. And they did. I'm still in pyjama. I'm still shaking. I sent Rai Weiss flowers already a week ago. And I wrote, Rai, your contributions to physics rank among the most important of all times. And these flowers are in anticipation of your Nobel Prize on October 3. I was so certain that he would get the Nobel Prize that I sent him flowers already a week ago. Apart from the incredible accuracy of LIGO, apart from that, which is enormously impressive, this was the last sliver left of Einstein's theory of general relativity to be demonstrated, to be proven. That space, time, as we say, can get warped, can change. It's a strange concept. That space, the size of space, everything, including your body, can do this when gravitational waves pass you. But it takes something as brilliant as LIGO, 4 kilometers long, to detect the change, which is 250 times smaller than the size of a proton. I was up already at 4:30 and I watched live the announcement in Stockholm on my TV. It came at 5:48 my time. I had tears in my eyes. I really did. I've been waiting for this a whole year. I have no words for this. It's so fantastic. It's physics at its very, very, very best. And this one we owe to my friend and former colleague Rai Weiss, who already thought of this, thought of LIGO, on the concept of LIGO more than 40 years ago. Okay, I thought you should know this. Take care and have a nice day.